Good afternoon. Today we're going to be looking at some applications involving exponential functions and maybe even a logarithmic function will pop up. We'll see. So you're going to need a calculator with an ln key on it. You'll also need one with the e to the x, and on this one the e to the x shares with the ln, but that's later on. We're going to need the little caret top exponent key for punching in an exponent like this one here on problem number 1. Let's look at problem number 1. The total number of public electric charging units available for hybrid vehicles has increased exponentially since 2006. The number of outlets A of t at these alternative fueling stations t years after 2006 can be approximated by, so here it is, A of t equals 220 times 2.61 to the t. Notice this is an exponential function because the variable is up there in the exponent, where t equals 0 corresponds to 2006. So this is the number of years after t is the number of years after 2006. So how many outlets were available in 2008? Or were available in 2008, 2010, and 2011. Okay, let's see. Okay, I've written down the problem. Now, this is going to calculate the number of electric charging stations available. T equals 0 corresponds to 2006. So, in 2008, how many years after 2006 would it be? Well, 2 years. Okay, so I'm trying to show to get that t value, you're subtracting from 2006. So we plug a 2 in for t. So what we're going to have to punch in will be 220 times 2.61 squared. Well, let me turn on my calculator. You're going to be using a calculator on every one of these problems. I punch in 220, and you can just say times. I think I'm going to do it the way it's written. Parentheses, 2.61. Close parentheses, and if it were any exponent other than square, I would use the arrow or the caret top, but I'll just hit the square key right there. And let's see what we have. 1498.662. I didn't read how to round it, but I suspect they're going to want us to round to an integer because it wouldn't make sense to talk about 0.62 charging stations, right? The number of outlets available in the year 2008 was approximately, round to the nearest integer. So am I going to leave this as 98 or should I make it a 99? 1499. The digit after the decimal point is a 6. So if it's 5 or bigger, you round up. So 1499. Okay. And now, okay, what about 2010? Well, in 2010, 2010 would be how many years after 2006? Well, 2010 minus 2006 is 4. So we're going to be punching in, plug a 4 in for t, so 220 parentheses 2.61 to the 4th power. So 220 parentheses 2.61 close parentheses. Now here's where I'm going to go raised to the 4th power. So we're getting 10,002. We're rounding to the nearest integer. So am I going to leave this 10,209 or make it 10,210? Well, the digit after the decimal point is a 0, so it's going to just stay 10,209. 10,209. 10,209. Now we're up to 2011. Oops. Well, what would the t value be for 2011? Well, it's 1 year more than 2010, so 5. Hopefully it's clear how I'm getting these t values. Just subtract 2006. 2011 is 5 years after 2006. So plug a 5 in for t. Let's see what we get. Should we expect more or less? Well, we should be expecting more than the previous answer. 220 times 2.61 raised to the 5th power. 26,640. Should I make it a 45? Leave it as a 45 or make it a 46? The digit after the decimal point is a 5, so you round up. 26,646. 26,646. Okay. Number 2. The percentage of executives in a certain industry receiving cash signing bonuses is increasing. The percentage is given by the function b of t equals 4.878 times 1.4343 to the t, where t is the number of years since 1990. So, since 1996. So for 1996, t would be 0. For 1997, t would be 1, and so forth. Find the percentage of executives receiving signing bonuses in 2002 and in 2003. Let me clear off this calculator. Okay. So, I've written the problem. T is the number of years since 1996. Okay, well, for 2002, what would the t value be? It would be 2002 minus 1996. So 2002 is 6 years after 1996. So we're going to be punching in 4.878 times 1.4343 343 to the 6th. Okay, I'm plugging the 6 in for t. So let's see, how do I do that? 4.878 parentheses 1.343 close parentheses. Now to enter that 6 as an exponent, I hit that key, 6, enter. So we're getting 28.62186. I should have looked to see how are we told to round this. Let's see. Round to the nearest tenth. So that means one digit after the decimal point. Will I leave it 28.6 or make it 28.7? Well, the digit after the 6 is smaller than a 5. It's a 2, so that's going to mean just drop all of that and leave it as 28.6. Next part of the question. In 2003, t would just be 7. So 4.878 times 1.343 to the 7th power. Let me see. On this one, if I just want to take the previous entry, I can go second and entry and just go back and replace that 6 with a 7. I guess it doesn't save much time, but you could do that. So 38.439. Now we're told to round to the 1 decimal place, to the 10th place. So it's going to be 38.4. The digit after the 4 is a 3. So 38.4% of the executives will receive signing bonuses, or did receive them. 38.4. Okay. Let's see. So we're just reading these problems, and basically you're going to have a calculator to plug into the formula that it's given you. All of these are exponential functions so far. Notice how the variable's up there in the exponent. The number of concurrent users of a social networking site has increased dramatically since 2004. By 2013, this social networking site could connect concurrently 70 million users online. Okay. The function, here comes the important stuff for the problem. The function p of t equals 2.402 times 1.488 to the t, where t is the number of years after 2004. This function models this increase in millions of users. Estimate the number of users of this site that could be online concurrently in 2005, 2009, 2012, and it says round to the nearest million users. Down here, you'll notice round to the nearest whole number. Let me make a note of that. Round to whole number. There. I think I've written everything down. If not, I'll just come back and... Okay, so t is the number of years after 2004. So for 2005, t would be 1. So we plug a 1 in for t. 1.488 to the first power, it's just 1.488. So really all you're going to be doing on this to do the first one is just multiply 2.402 times 1.488. 3.574, but we're rounding it to a whole number. What will that whole number be? Will I leave it as a 3 or make it a 4? 4. So in 2005, the number of users on the site was 4 million. Okay, now let's do 2009. Let's find our t-value. Oops, 2009. T would be what? Since 2004, would I just subtract 2004? So T is 5. So it's 5 years after 2004. And we're going to punch in 2.402 times 1.488 to the 5th power. So 2.402 parentheses 1.488 close parentheses raised to the 5th power 17.522 ... Rounding to a whole number, will I leave it as 17 or make it 18? Well, since the digit after the 17 is a 5, we're going to make it an 18. So in 2009, there were 18 million users. The number of users, okay, but what about 2012? Oh, is this the last part? Yeah. Well, for 2012, T would be, well, not one more. 2012 is how many years after 2004? Would it be 8? Again, you subtract 2004. So you're going to punch in 2.402 times 1.488 to the 8th power. You know, it's just the same thing as this one here. I could go second entry and just move back and replace that 5 with the 8. Enter. 57.729. Okay, so 57.729. We will round that how? Oh, and what you're seeing right now is one of my cats has gotten up on the table with me. So ignore that fur right there. Let's see, 57 or 58. How would I round it to the nearest whole number? 58. Oh, okay. Got him off of there. As I'm doing this at home today. It's video 58 million. Do y'all agree with rounding the 57.7 to 58? Okay, number 4. The exponential function h of t equals 8030.18 times 1.0488t, where t is the number of years after 2008, can be used to project the number of centenarians in a certain country. So that predicts the number of people that are 100 years or older. Use this function to project the centenarian population in the country 2005 in 2013 and 2034. Okay, let me write all of this down. 2034. Yeah, just noticed this up. Well, hopefully by now you're getting the hang of all of this. I may as well clear off this calculator. Oh, let me see. H of t is 8030.18 times 1.0488 raised to the t power. T is the number of years after 2008. So for 2013, t would be, if I subtract 2008, am I getting 5? So I need to punch into my calculator. 8030.18 times 1.0488 to the t power. And of course, I'll see if he'll just sit in my lap. Sorry about that cat there. So now punch all of that in. Let me see. 8030.18 parentheses 1.0488 raised to the close parentheses raised to the 5th power. Now let me see. 8030.18 times 1.0488 raised to the the 5th power. Here he comes again. This cat's name is Butter. And there, I'll just make room for him to stay there. Hey, we didn't look and see. How do they want us to round this? Round to the nearest whole number. Okay, rounding to the nearest whole number. 101,558. Well, wait. Will it be 558 or 559? Well, the digit after the 8 is a 7, so we're going to make it a 9, aren't we? So, according to this function, come on, let him see. See the problem I'm working. There. So according to the function in the year 2013, there's going to be 101,559 people that are 100 or older in this country that they're talking about. $101,559. Now, let's go way off into the future, the year 2034. If I subtract 2008, what's my t value going to be? Is it 26? 2034 would be 26 years after 2008. So we're going to punch in, oh wait, I'm sorry. There. So we're going to put a 26 in place of t. So 8,030.18 times 1.0488 to the 26th power. I'll go second entry and just go back and replace this 5 with 26. Oh, okay. Oh, butter, come on. Yeah. You just sit right there, okay? Sorry about that. 276,220. If we're rounding this to the nearest whole number, do we leave it as a 5 or make it a 6? Well, the digit after that decimal point is just a 2, so we'll just leave it as a 5. So in the year 2034, we should expect 276,225 centenarians in this country. Whatever this country is that we're talking about. 276,225. Now, let's see. Here's another one. The demand for lumber is increasing exponentially. The amount of timber in billion of cubic feet consumed T years after 1997 can be approximated by N of T equals 61 times 1.018 to the T, where T equals 0 corresponds to 1997. Okay, so we're told to round to the nearest hundredth. Let me make a note of that. Round to hundredth. Okay. Okay, so we're rounding to the nearest hundredth. Okay, so in 1998, well, that wouldn't be hard to figure out. T is just 1 year after 1991. So we're going to punch in 61 times 1.018. Look, anything to the first power, that's just, I should have already cleared that off. Well, 1.018 to the first power would just be 1.018. So we're just punching in 61 times 1.018, 62.098. If we're rounding to the nearest hundredth, that means 2 digits after the decimal point. Tenths, hundredths. Am I going to leave this as a 9 or make a 10 out of that? Well, since the digit after the 9 is an 8, we're sure going to round it up. 62.10. So in the year 1998, based on this function, the demand for lumber was 62.10. Okay. Now, the next part of the question. What about the year 2000? How much lumber was consumed in 2000? Well, the year 2000, T would be what? Minus 1997, that would be a 3. So 61, plug a 3 in for t. 61 times 1.018 cubed. So 61 parentheses 1.018 close parentheses raised to the third power. Oh, it's a long one. 64.35364. Now, we're trying to round it to the nearest hundredth, so there should be 2 digits after the decimal point. This 5 here, do I leave it as a 5 or round it up to a 6? Well, I just leave it as a 5 and drop all of that because the digit after the 5 is a 3. So 64.35. So 64.35 billion cubic feet. Now, what about the year 2010? In 2010, what? 2010, what's our value of t? Well, if I subtract 1997, is that going to give me a 13? Was 2010 13 years after 1997? Yeah. So t is 13. I'm going to pitch it. 61 times 1.018. Plug a 13 in for t. To the 13th. So I'm just second entry, go back, punch in a 13 for the exponent. It's place of the 3. 76.922067 ... It goes on and on. Rounding to 2 decimal places, the 100th place. Do I leave it as a 92 or make it a 93? Well, the digit after, next digit is smaller than a 5. So we're just going to drop all of that and leave it as 76.92. Ooh, 76.92. Okay. A restaurant purchased a 72-inch range with 6 burners for $7,464. The value of the range each year is 72% of the value of the preceding year. So that means that each year it's losing 28% of its value. After t years, its value in dollars is given by the exponential function v of t equals 7464 times 0.72 to the t power. Find the value of the range after 0, 1, 2, 4, and 8 years. Okay, so a little bit of a depreciation problem. Well, after 0 years, let me see if I got written it all. I think so. After 0 years, that's when they bought the oven, the range. If we plug a 0 in for t, remember that rule about a 0 exponent? Anything to the 0 power, that's just a 1. after the 0 years, you've just bought it. It costs $11,464. So we're assuming that's what it's worth. If you actually punch that into your calculator, 7464 parentheses 0.72 raised to the 0 power. What the calculator is going to do is say 0.72 to the 0 is 1 times 7464 is 7464. So after 0 years, 7464. Oh, I should make a note. We're round to the nearest dollar. Nearest dollar. Oh, check it. So after 1 year, plug a 1 in for t. So we have 7464 times 0.72 to the first power. Well, to the first power, it'll just be 0.72. So really all we have to do is multiply 7464 times 0.72, 5374.08. Well, we're rounding to the nearest dollar. So would that just stay 74, or do I make it 75? Well, it's going to stay 74. So 5374. 5374. So the value of the range after 1 year is approximately 5374. Now after 2 years, after 2 years, 7464 times, replace the t with a 2. So punch in 7464 times 0.72. Since it's just a square, I'll hit the square key. 3869.33 . We're rounding to the nearest dollar, so do I leave it as 69 or make it a 70? We leave it as a 69. So after 2 years, it's worth $3,869. So $3,869. Okay. What about after 4 years? So plug a 4 in for the t. So it'll be 7464 times 0.72 to the 4th power. Oh, wait, there it is. So 7464 parentheses 0.72 close parentheses raised to the 4th power. 2005.86 ... Important thing is this 8. I'm going to leave it as 2005, or does it go up to 2006? We're going to round up, aren't we? So 2006. Okay. And then finally, after 8 years, Do we expect it to have a higher value or a lower value than 2006? Well, it better be a lower value. So here we go. Put an 8 in for t. 7464 times 0.72 to the 8th power. Second entry, back arrow, and replace that 4 with an 8. Ooh, okay. $539.05. We're going to round that just to 539. So after 8 years, it's lost almost all its value, hasn't it? It's worth $539. If I was saying 5,000, I'm sorry about that. $539. Okay. Okay, now what's this one? A company begins a radio advertising campaign in a city to market a new CD-ROM video game. The percentage of the target market that buys a game is given by the function f of t equals 100 times 1 minus e. Remember that e on my calculator, the e key shares with the ln. So I'm going to have to hit second before I can get to that e to the x key. Negative 0.07t, where t is the number of days of the campaign, and f of t is the percent. So when you plug in a number for t, it's going to give you the percent. Find the percent of target market that buys a game after a 30-day campaign. So based on this function, how many people are going to buy it? Well, on this one, we're going to plug a 30 in for t. Okay? So we're going to have 100 times 1 minus e to the negative 0.07 times t. I'm going to say times 30. We plug the 30 in for t. This is going to be a little messy. Okay? Here's what I'm going to do. Let's just break this up into a couple of parts. I'm going to go ahead and multiply the negative 0.07 times 30. Negative 0.07 times 30 is a negative 2.1. Okay, so here's what I'm going to be punching in. 100 parentheses 1 minus e to the negative 2.1 power. I think that'll be easier than punching this all in like that. So I'm going to start punching it in. 100 parentheses 1. Now this is the subtraction key. Down here's the negative key. So minus, to get to my e to the x key, I go second ln. That gets you the e raised to the, now put in negative 2.1. And now, every time there's a parenthesis open, make sure you close them. So I'm going to close the one here. And there's another one here. There. So we have 87.75435,717. I should have made a note. How did it say to round this? Let's see, let's look. Round to the nearest hundredth. Hundredth means 2 digits after the decimal point. So 0.75. Am I going to leave it at 0.75 or should I make it a 0.76? Well, the digit after that 5 is smaller than a 5, so we just leave it as 87.75. 87. What percentage of the target market is predicted to buy a game after a 30-day campaign? 87.75%. Is there another part to that? Oh, no, that's it. Question 8. The average walking speed of a person living in a city of population P in thousands is modeled by the function R of P equals 0.37 ln P plus 0.05. That's an ln, natural logarithm key on your calculator. The population of Boston is 532,000. Find the average walking speed of people living in Boston. That's an interesting formula here. I never would have thought of walking speed being determined by population, but now that I think about it, it sort of makes sense. If you're in a city where the sidewalks aren't packed full of people and there's not a lot of cars, you can walk pretty fast. But if you're in a city where the sidewalks are just jam-packed with people and there's a whole lot of traffic, then the walking speed would be slower. Okay, I think I've written it down. But maybe something's wrong. Okay, we're going to find the walking speed of a person living in Boston where the population is 532,000. Well, notice I wrote that P is the population in thousands, which means the P that I'm going to plug in for isn't 532,000. It's just 532. Y'all see why I marked off these 3,000s? P is not just population. It's population in thousands. So we're going to plug a 532 in for P. So we have 0.37 ln P plus 0.05. Now, when we punch this into our calculator, there's a couple of tricky things about this problem. It has that P is the population in thousands, so you don't punch in the thousands. You don't enter the thousands for P. But also, whenever you hit the ln key, at least on my calculator, it opens those parentheses, which means I'm going to have to close them. Okay? If I don't put this red parenthesis here, if I don't enter that, it's going to give me the wrong answer. Okay? So I put 0.37 ln. Notice how it opened. If I don't close this set of parentheses, then it's going to treat this 0.05 as if we're taking the natural log of that also. And it's not. We're only taking the natural log of P, 532, plus 0.05 enter, and 8. I should have looked to see how we round. Round to the nearest 10th. Okay, rounding to the nearest 10th. Will I leave that as a 3 or make it a 4? Well, the digit after the 3 is bigger than a 5, bigger than 4. So make it 2.4. The digit is 5 or larger, you round it up. If it's 4 or smaller, you just drop all that decimal stuff. So here, 2.4. So the walking speed is 2.4 feet per second. Wonder what it is in Corpus Christi. That's where I am right now. Corpus Christi, Texas. The population of Corpus Christi, is that like 350,000? So P would be about 350, just out of curiosity. 0.37 ln 350 close the parentheses plus 0.05 2.2174. Well, you know what? In Corpus Christi, it's always so much harder than in Boston. People have to work slower here, okay? Again, I don't even know if this is a real formula or if they're just making it up. But either way, I'm just killing time now. We are finished. There we go. And I'm just going to say thanks for watching. And I hope you have a good time working on these word problems. Bye-bye.